Okay, Eliana, are you ready to learn how to find the volume of irregularly shaped objects?
Yeah.
What do we have today?
We have a rock and a car.
Okay, so I'm going to do a little mini lesson first, and then we'll get started on our activity. Okay? So we're going to learn, and I think you guys have done this in chemistry class already. We're going to use displacement to find the volume of objects for which we can't easily find the volume. Okay, so this formula, volume equals, capital B is still base area. That little triangle with the H, that's delta H. Okay, write this in your notes. Delta H, delta is used for a change in something. So we're looking for the change in height. We're going to use water and displacement to help us do this. So imagine that you took an irregularly shaped object, and I'll link to the book's nice little description of this as well. We're actually going to use volume of water in a container for which we can find a volume. So I just have a nice straight cylindrically shaped cup here.
Oh, let's try the car first.
Okay, let me give them a few more directions and then we can start. So what will happen is, imagine we drop one of those objects in. Go ahead and do that, Eliana. Gently set that rock in there. That rock, you'll see this phrase in the book, displaces its amount of water, its volume's worth of water. So it's almost like you could imagine, and we'll mark this in a second here. As this rock goes in, the whole water level, Eliana, what does the whole water level do?
It was trying to push up with a rock.
Yeah, kind of push the water up. So there's more stuff in there. So we just have to figure out how much more stuff is in there.
Okay, we started from the bottom. The bottom starts from
Okay, let me give them a few more instructions first. Then we'll take our measurements, okay?
Okay.
Okay. All right, so pause 1 second here. Okay, so first, if you're going to try this at home on your own, make sure you calculate the area of your base before you put the water in. We did this before. We have a circle as our base. We found our radius of 3.5. There's our base area. Now, you can actually do this two ways. Since we already have the rock in there, we can do what Eliana was doing, and we can take our measurement initially, because we don't really care if the water level is going up or down. We just need to know the change.
Of the top, I think how we need to measure it at the top is on this side.
Yeah, we should use centimeters. That's a little bit easier. So let me see that here. We're going to measure. I'm going to move this to the edge so we make sure we get the 0 mark here. Okay, so our initial, actually, here, we're going to do this. If you have a dry erase marker, you can actually just write on your cup where the water level is. We're going to measure from the bottom up to that water level. So let me take our centimeter ruler here. We're going to go from the bottom up to that water level. We are at about
10, I think.
Yeah, almost. Just before that. So like, let's say 9.7. Okay, so we're going to make a little note of that. Our initial water level to find our change in height. We're going to take our initial water level. And then, Eliana, we got to take the rock out. You can take the rock out of there. You can just use your hand.
Cool. That will work too.
We could find the volume of your hand. Take that rock out.
Take the rock out.
Now try to get all the water off of it in the cup if you can. Shake it off. Okay, then you can set that on the paper towel.
I try my hand back.
Now, Eliana, come here. Look what happened. What do you think happened to the water level when we took the rock out?
It shrank.
It did. It went down a little bit. So now we're going to mark our new water level. And we can do this one of two ways. We can find delta H by just subtracting the two to find the difference. So we could say, okay, now that's at about, thank you, 8.9.
I'll hold on to that so it doesn't fall off the edge.
So that is what, 0.8 of a centimeter we've changed.
Mama,
but you can also just...
Can we try my hand now?
Sure, we'll do that next. We can also just measure the change in height itself. So if you just measure the distance between those two marks, so imagine that's like that slice of water that was sitting on top. That right there is about 0.8 centimeters. Okay, so then to find the volume of the car, we're just going to take area of the base times the change in height. So this 38.48 that we found earlier before we started the video times 0.8 centimeters. Let me see what that is. Times 0.8. About 30.8
centimeters, you want, right?
Yes, and we're talking about volume, so this is cubic centimeters. That's the volume of our rock. Okay, shall we try your hand?
Yeah.
Okay, let me erase this. Get this rock out of here.
I'll get that rock.
Okay, let's erase this.
It's gonna be nice and shiny to go back on my rock collection.
Okay, so we're gonna mark the original water. Now we're gonna do it kind of the opposite way. So I'm gonna have the water level marked initially, then we're gonna put your hand in and I'll mark the new water level. Okay, just try to get up to your wrist in the water. Go ahead. Okay. Now look how high the water went up. Oh my gosh. Okay, take that out. Now you can dry it off. Now we'll measure our change in height. And this time I'm just going to strictly measure the distance between them. I'm not taking two separate measurements. So we're at 3 centimeters. Okay, so we're not going to do the, oops, I mislabeled here. This was the rock that we just did. Now we did Eliana's hand. What did I say that was? 3.3?
Yeah, 3.3 probably.
3.3 centimeters. So
Maybe
the
we
volume of
should
your
mark
hand.
The measurement so we remember where it is.
That would have been a good idea. Yeah, or write it down at least.
Yeah.
Through 30. Okay, so we're doing our base area again times our change in height. I just measured the distance between those two markings this time.
And I got my hand.
Yeah. Let's see what the volume of your hand is. What do you think? What's your guess, Eliana? What number do you think it's going to end up? How many cubic centimeters could you fit in your hand?
I don't know, but I think a lot.
Yeah. More than the rock?
More than the rock.
Oh, yeah. Here's our final answer. 128 cubic centimeters, Eliana. 128.
Oh my God.
Is that a lot? Okay, thanks for being my helper today. Say bye and make sure they do the practice problems. Tell them to do their practice problems.
And how you do them.
What? What does that mean? Just tell them they need to make sure they do their practice problems.
And don't do them like anybody else's.
She means no cheating, right? Okay, good idea. Thanks. Bye.
Bye.